All right, let's do a quick review of FTC number 2. All right, so the bottom line is that integration and differentiation are inverse operations. So if I'm going to take the derivative with respect to x of an integration that goes from any constant to a expression in terms of x of f of t dt, we're going to end up with f of g of x times g prime of x. A simple example, if I'm going to integrate 2t dt, and let's go from 10 to x cubed. We all know that the integration of 2t is t squared. This is a definite integral from 10 to x cubed. Using FTC number 1, we get x cubed in that, where t squared is, minus 10 squared. Now, if the problem said integrate and then take the derivative, I'm going to come down here and something I've already integrated, and I'm going to take the derivative. Now, the derivative of any constant is 0, and we're going to use the chain rule to take the derivative here of x cubed squared, and so that's going to end up being 2 x cubed to the first, and then multiplied by the derivative of that inside piece, the chain rule, so we get 3x squared. Now, if we notice our original integration problem, we have a 2x there, or a 2t, and so here, down here, we have a 2, and this is where the t used to be, so 2t, and instead of the t, we have the x cubed, and we have placed that x cubed right where the t was. And then the only difference here is this is our g prime. So if you think about it, this is twice our g prime, or g of x times g prime of x, right? All right, so let's do something just a little bit more straightforward without integrating first. So if we want to differentiate, and we'll go from any constant, we'll just say we'll go from 2 to 5x of, say, 3t plus t squared dt. Now, we could eliminate or ignore momentarily this ddx and just integrate and apply FTC 1, f of b minus f of a. But if we're going to, let's leave this as taking the derivative with respect to x, what we can do, FTC number 2 tells us that we can just take our function with respect to x, place it wherever there's a t, and then also, then I have to remember to take the derivative of that function in terms of x and multiply that like the chain rule. All right, so now we're going to say 3 times your 5x plus your 5x quantity squared. And then I'll have to multiply it by the derivative of that g of x, which is 5. Right? Now, if we do it the long way, integrate first, from 2 to 5x dx. So we know how to do that. So it's 3 halves t squared plus our 1/3 t cubed from 2 to 5x. All right, let's using Ftc 1, placing f of b. Here's our placing b, which is 5x, and then minus f of a, placing our 2 into our function. Kind of a mess there. All right, now the original problem said, let's take the derivative. And when we do that, and applying chain rule, we get 3 halves twice 5x to the first times 5, derivative and apart, plus 1/3 times 3, 5x to the first times 5. And we know that the derivative of all this mess is going to be 0. We have a 5 in both pieces. Let's factor that out. We can cancel a few things out. We have the 5 that we factored out. We're left with 3 times the quantity 5x to the first plus 5x squared. And lo and behold, that's exactly what we got before. All right, let's come up with a crazy example. Start with pi, go to, let's say, sine x of the square root of t cubed plus 3t squared dt. And our fundamental theorem of calculus number 2 tells us that we're going to differentiate and we're going to integrate inverse operations. Our function is sine x. We're going to place wherever there's a t. And just we need to remember to take the derivative of sine x, like the chain rule. So here we go, square root of sine x quantity cubed plus 3 times sine x quantity squared, all times the derivative of sine x, which we know is cosine x. And there we go. Shebang.